My name is Fabio Tilim. I'm with Apex Voice Communications. I'm VP of Sales. I'm here assisted by Danny Gomez, a Senior Project Manager. We're going to be doing a practical presentation of WebRTC. Something going on here, excuse me. SIP and video, WebRTC and SIP video conferencing solution and demo. I'm going to start with a brief few slides about the company, about the solution, and then we're going to actually show you a running demo right here. Apex Voice Communications has been around for over 20 years. Our focus has always been network services, customer service, and value-added service for TDM and IMS network service operators. Product is called the Apex Service Delivery Platform, with our product being the Omnibox 3D application server, which provides interactive voice, SMS, USSD, and video services applications for telecom networks. We have also licensed our application server software to a number of telecom equipment manufacturers and vendors, like the ones you see on the screen. Product is deployed globally in over 95 countries, in over 250 telecom service providers in a variety of applications that run on our Apex Service Delivery Platform. The main components of the platform are the Omnibox 3D application server, which takes care of the signaling, session, and application control aspect of the solution, as well as the Apex Media Server, which takes care of the SIP multimedia processing. In effect, is a media resource function in an IMS network. And on top of that, the OmniViews console, which provides the operations, administrations, and provisioning of the platform, as well as the service creation aspect. We have this OmniView screen right here, gives you an idea of the graphical user interface. It's a drag-and-drop environment. We provide all the tools that you would need to provide telecom side services, as well as data side interaction with databases and data sources. What we're here to present today is our Care Cloud conferencing system for telecom network operators. Basically, it allows the network operator to host multi-party conferencing. And the idea is that most enterprises today have a video conferencing solution. Through the Apex Cloud conferencing system, telecom service operators are able to bridge diverse video conferencing systems from different enterprises, so an enterprise can interact with their video conferencing with perhaps their vendor, the customers, by using the Apex Bridge. In effect, what we're doing is making the video conferencing as accessible as audio conferencing services. So the Apex Service Delivery Platform targets specifically SIP and IMS networks. So it supports traditional real-time protocol and also H.264 and H.263 video codecs. What we did is add support for secure RTP and the VP8 video codec, so we can provide support for WebRTC. So in essence, we're mixing these codecs and this transport to process calls from SIP clients, as well as VoLTE handsets, and of course HTML5 WebRTC-enabled browsers. And we do that SIP over WebSocket transport. It also takes care of the transcoding, so there's no transcoding required at the edge of the network. And it also interacts with existing infrastructure. So we support WebRTC to SIP session border controllers provided by the traditional telecom vendors. So in the most of web conferencing solutions that we see today, the challenge is that you're receiving a video stream from each participant on a peer-to-peer situation. So in essence, if you have, say, 8 peers talking at one point, you're going to need about 1 to 2 megabits per second per each peer, which roughly will require 8 to 16 megabits of bandwidth, which makes it unworkable for bit streams rates of VGA or 720p resolution. Imagine a small office, 3 or 4 people participating in the same video conference, what a headache that would be. What we do is we take care at the media server level, we do the transcoding, we do the mixing, so that we can deliver to each endpoint, whether it's SIP or WebRTC, from the MRF, the appropriate resolution with the 8 tiles all mixed in, so only requiring 1 to 2 megabit per second per conference. So the bandwidth requirements are minimal. And we can do this to deliver to SIP clients or to WebRTC browsers. And we identify when the caller registers what kind of device and what is the resolution requirement, so we make sure that we deliver back to that device that specific resolution for the form factor. So what we're going to do right now is do the demo. So what we did here is, we lost power, I'm told. Okay, we may be able to get it back quick. So basically what we attempted to do here is to replicate the solution running on an AMS network. What we have is a server running the Omnibox 3D application server, which you see on the right side of the screen, and the Apex Media server on another server running on the left side of the screen. We're using the wireless access point as network, and then we have PCs running Chrome, as well as some iPad and iPhone devices to do the video conference. Any luck? No. Okay. While he tries, I have a slide of basically here what you see is a Chrome browser that is being delivered from the media resource function. The RTP, will carry 1 to 2 megabits, even though it's showing 4 people, for peers. And this is mixing SIP and WebRTC, and the bandwidth requirements is only 1 to 2 megabits per second. So another thing we can do is we can inject media into the conference bridge. This could be live video, it could be an RTSP security camera, it could be a YouTube video in the internet, and so that family, friends can share and experience something like a soccer game. All right, so he's trying. I'm going to give him another minute. Meanwhile, basically what Apex provides is a software-based solution. Our core product is the application server. Show you a slide before of the OmniView service creation environment. Very powerful. It allows our customers, which we train, to be able to create any type of multimedia service for voice, for video, for SMS and USSD. This is actively deployed around the world, running video conferencing, running all sorts of interactive voice response, network IVR, network ACD, automatic collect calling, prepaid calling for pay-per-call mobile networks, for example. And? Well, we're running out of time, so if there is any questions, I'll take them while we give it another try for another minute. We good? Yeah. We're good. They tell me we're good. Okay, let's try this. Let's see. All right. Here's Chrome. Put our credentials, join the meeting. And we need to allow. We allow. There is me. And there is the splash screen. Oh. I don't have it. No, I didn't close it. Did I close it? All right, let's try this again. I'm sorry. Join meeting. Join the video conference. Allow. Well, resolution is cutting it off. This is a splash screen. Move it what?
No, move this over.
Full screen? Oh, there we go. All right, so there's the iPad. We're going to put the iPad on. So here you see myself. You see the text overlay with my name. This is picked up through the signaling. So if I'm calling from any type of SIP device, for example, where I have my credentials, we'll pick it up and put the text overlay. You see this camera right here with Danny. And then we're injecting video into the bigger tile. We can provide any type of layout, different layouts. This is a 6 layout for up to 6 participants. And here we should have a 9 layout, and the bottom one is showing the iPad that you see, Danny. And time is out, so thank you very much. Have a good evening.